I think everything is settled down, and we are in the new weekend of Lagrangian formulation. So today, in last class, I've seen that how uh, we have just understand what is equation of constraint, degree of freedom, and I have just give the definition of variational method, and now I will start from there, and then we will go for Lagrangian formulation. So today we will just formulate the Lagrangian part, but before that, let's go for again variational method. What is this? And let's say go for this particular thing. So what is variational method? We have, suppose, integral, and this integral is function of some variable y dot and x dx. We can go from any point x1 to x2, and what is y dot? Y dot is dy upon dx. So this is just a mathematical term, and if del I is equal to 0, which implies del variation of x1 x2 f y dot x dx must be 0, then this f will follow. Then f as a function of y dot x will follow Euler-Lagrange equation, and which is given by d upon dx del f upon del y dot minus del f upon del y. So this is the whole statement. Now, this is the wonderful method to get the maxima, minima, or extremum of any particular extremum path and optimization process. So we can use this as a mathematical tool to get the optimization process. So, for example, if I will ask you, suppose we have y versus x, and there is a point A and another point is B, we can have n number of path. We can have n number of path. You can go from any path. But in a plane, the shortest path is given by what? A straight line. Shortest path is a straight line. So we can prove this particular thing such that you have believe on this particular mathematical formulation. So let's try to prove that shortest path between 2 points in a plane is a straight line. So what I need to prove? The shortest path in a plane is a straight line. What I need to prove this thing. The shortest part in a plane is a straight line. Let's try to prove it. This is just a mathematical exercise, nothing to do with your examination, but yes, we should know what is actually this is given as. So when we have this kind of situation, so what will be S? S is the any path, and we can just go for, suppose this is, I am taken, this is point A and point B, and this is some path S. And what I have to do, I have to just extremize this X. So what I am going to do, I will take, suppose this is Y and this is X. I will take a very small element of this particular thing. I am just taking very small element. This is nothing but ds. I will make it zoom part. So whatever this part, I am just doing this thing. So this part is ds. So obviously this is dx and this will be dy. So what I am doing, I am just zooming it, isn't it? I just take this part and I zoom it and I show you what is there. So I have just talked about this shortest path. This is a small element of ds. So when we have a small element ds, what is s? S is nothing, integration of this particular ds. If we will go for integration, then we will get the s. And what is ds? If ds is very small, if ds tends to 0, this will be approximately straight line. If ds tends to 0, I have make it very bigger such that you can just visualize it. But if dx tends to 0, this will be approximately straight line. So mathematically what I can write ds is equal to root under dx square plus dy square. So what I have to do, I have to just go for s as this will be something dx square plus dy square. So I will just keep it in form of y dot, and I just want to write this is in form of something y dot and x. So I just want to write this thing. So I can take something common. So this will be root under 1 plus dy upon dx square dx, and this will be my s. So if you have any doubt, you can just ask me, then I will go for further calculation. If you have any doubt, you can just ask me. Otherwise, we will go for further calculation. Okay. So now, so this term, so this is the s, any s. What we have to do, we have to extremize this s. When this s will be extremum, then this del variation must be equal to 0. The first order derivative must be equal to 0. You know from the maxima and minima. Now, so we have this condition. So we have condition of if, because x is extremum. So this is talking about s is extremum, then this must be equal to 0. Then obviously, what is my f? I have recognized my f, and this f is, so I recognize my f, and this f is nothing but root under 1 plus, what I can do, I can write it y dot square. So 1 plus y dot square. Now, if this is going to happen, this f will satisfy Euler-Lagrange's equation. So what is Euler-Lagrange's equation? We have d upon dx del f upon del y dot minus del f upon del y must be equal to 0. Please note down that these are only partial differential with y, and this is partial differential with y dot. So what will be, so if this is my f, then del f upon del y must be equal to 0, and del f upon del y dot, you can just differentiate it. First I will differentiate root, so half will be there. Then I have to differentiate y dot, then 2 will be there. So I think we will get y dot root under 1 plus y dot square. So this is wonderful example of, so this is wonderful calculation. What we have to do, we have to put it here. So we have d upon dx y dot root under 1 plus y dot square minus 0 must be 0. 0 is for this. What is meaning of that? Meaning of that, this must be constant, because the right hand side we have 0. Then we can easily say this y dot upon 1 plus y dot square is equal to, let's say, some alpha. This must be constant. only constant value of differentiation, that is 0. So we are using this particular thing. Now, when we are using this particular thing, then we can just solve for the y dot, and we have y dot square. I am squaring both sides. Alpha square 1 plus y dot square. And now I will collect y dot square, and this will be 1 minus alpha square is equal to alpha square. What I can write, y dot is equal to alpha by root under 1 minus alpha square. So constant by constant is, let's say, some constant m. So I can assume this is m. And what is y dot? Y dot is nothing but dy upon dx is equal to m. And when you are going to integrate it, you will get y is equal to mx plus c. C will define from the initial condition. What is your initial condition? But the main thing is this equation is nothing but what? Straight line. So you can see that this is a wonderful and very strong mathematical tool such that we can talk about extremum and all kind of situation. If you have any doubt, you can just ask me. Then we will go for in our mainly Lagrangian formulation. That is the main thing we have to do.
सर ये एफ के इक्वल कैसे रख दें, समझ नहीं आ रहा सर. एफ इज इक्वल
क्या
टू
हो गया?
एफ के इक्वल सर एफ इज इक्वल टू 1 प्लस वाई डॉट स्क्वायर.
अरे भैया मान लिया, मैं मान लिया, ये इस तरह का फॉर्म नहीं है. इंटीग्रेशन प्लस y डॉट स्क्वायर dx, जो मैंने पहले फॉर्मूला लिखा है वो ये नहीं है.
यस सर.
ये है, इसको आप नहीं लिख सकते f फंक्शन ऑफ y डॉट x dx. इसको इससे कंपेयर नहीं कर सकते.
ओके सर.
हाँ, तो उसको मैंने कंपेयर किया है. अब ये अगर 0 होगा तो ये वाला पार्ट को तो ऑयलर लैग्रेंज इक्वेशन समझना ही पड़ेगा. मैं तो कंपेयर किया हूं. ठीक है, क्लियर हुआ?
यस सर. यस सर.
Okay. Now, so obviously this is a very simple stuff. We can solve if we want to solve. Well, there are n number of problem on this. We can use the maxima, minima, and all kind of thing. But this is not for the physics class. This is actually for the mathematics class. So, but we physicists always try to use beautiful mathematics, and it is really beautiful mathematics. And on the basis of this particular beautiful mathematics, what you can see we make a mathematical philosophy of classical mechanics. What are the mathematical philosophy of classical mechanics? This is wonderful. Now, let me ask a very philosophical question to anybody of you. Suppose I have this particle. I think this is visible to you. This is a chalk and I have this particle. If I throw the particle in vertical direction, and suppose I have initial condition fixed and I am not going to change, and this will going to, and I am repeating this experiment again and again. I am repeating this experiment again and again. This particular particle will follow the same path. So suppose it is started from my hand and it will go up to this height. It will follow the same path. Either you can repeat this experiment 1 lakh times if initial condition is same and you are not changing the system. What is meaning of changing the system? There is same potential energy and same kind of environment is there, then every time it is going to same path. If I will throw it with angle, let's say some angle, then it will surely make the projectile motion. It will make the projectile motion. No matter how much time you can do this experiment, But the question is that why they are obeying same path? This is the fundamental thing. And this is one of the beautiful question and we have to ask. And this question have to, and the answer of this particular question is given by a beautiful mathematical interpretation, and that is principle of least action. And this principle of least action is actually the main mathematical philosophy of classical mechanics. What is principle of least action? Let's try to understand this thing. So we will go for principle of least action. Principle of least action. What is action? This is the most important thing. We have to identify what is action. So first, we defined action is a mathematical term. Be mature yourself. Be mature. Don't unnecessarily try to find what is physical meaning of everything. You are not in a position that you can get physical meaning of everything. You have to just look at around you, and the thing is that how beautiful mathematics can work. And what we defined a mathematical term action. What is this action? This action is pretty interesting. This is identified as L. L is some function. I am not saying this is Lagrangian right now. What I am saying L. L is function of generalized coordinate, generalized velocity, time, dt. So this is action. This is typical action. A is nothing but L qi dot t dt. So this is action. What principle of least action tell us? You can see. Suppose we have one-dimensional system and this is x versus t, and I just want to go from point A to point B. We can go like this, 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 we can go like this. There can be infinite number of paths. There can be infinite number of paths. If there is infinite number of paths, then what I can say, at some point of time t, we can have different value of y. The time t is equal to, let's say, t1, and we have here y1, we have here y2, we have here y3. This is not possible. This is not possible for classical system. This is not possible. If this is possible, then at same time, then particle can be different places. This is not the thing. So which path is going to chosen by particle? Which path it is going to choose? The particle will calculate itself, and which path is going to choose? He will choose only path. Now I am writing the principle of least action. Any particle will follow only those paths for which action of a system is extremum. So action of a system is going to extremum. What is meaning of that? If I define this is action, and I didn't define it, is defined by Hamilton's. So it is not Hamiltonian, it is Hamilton's. What is this xn? So we can write this thing. If any particle will follow only those paths for which xn of a system is extremum, meaning del variation of A, meaning we are talking about del variation of LDT must be equal to 0. And I can write L in a very detailed form. This is function of generalized coordinate, this is function of generalized velocity, and this is function of time, LDT. And obviously we are going from initial time to final time. Then this must be 0. Then this must be 0. Now, if we are going to compare it with our mathematical tool method of variational principle, what variational principle have said? The variational principle is nothing, the del variation of any function, and that will be y, and this is function y dot, and x dx must be 0. Then what we can do? We can compare these two integration. How you can compare these two integration? We can compare f to L, we can compare y to qi, we can compare y dot to qi dot, and yes, I can compare x to t. I can compare these all things. Then what will happen? This f will follow Euler-Lagrange's equation, then this L will also follow Euler-Lagrange's equation. And what will be Euler-Lagrange's equation? This Euler-Lagrange's equation for x is d upon del x del L upon del y dot minus del L upon del y equal to 0. Sorry, this is for f. This is for f actually. This is for f. If I want to write this thing for L, then what will be this particular thing? I am going to use this space. So this thing can be written as d upon dt, d upon dx, d upon dt, del L, del qi dot minus del L upon del qi, and this must be equal to 0. Del L upon del qi. This must be equal to 0. And this famous equation is known as Lagrange's equation of motion. This is actually Lagrange's equation of motion. Del L must be equal to 0. Qi, here is qi dot, here is qi, and this is known as equation of motion. Hence, I need this must behave like an equation of motion. Hence, I need that this must behave like equation of motion, means this must be equivalent to Newton's law. So this must, any equation of motion is nothing but the Newton's law. What I want this differential equation must behave just like a Newton's law. Then we decided, we have making lot of hit and trial, then we decided what should be form of L. And the form of L is very famous, identified as L is nothing but identified as kinetic energy minus potential energy of a system, and this is known as Lagrangian of a system. If L will be not a form of kinetic energy minus potential energy, then this equation will not act like Newton's law. So what we need the final solution be just like a Newton's law, because we firmly believe that Newtonian physics is the ultimate thing for the microscopic world. So what we have done very intelligently, we use method of variational principle and go for the principle of least action, and finally we get one particular equation, and this is differential equation. And this differential equation, what I need this must be act like as a equation of motion or Newton's law of motion. Means I have to keep my form of L such that it must be behave like a Newton's law of motion. So what I will choose, I have choose intelligently that L is equal to T minus V. Or if L is equal to T minus V, then this will just behave like a Newton's law of motion. And this is known as Lagrangian of a system. And this T is nothing but the kinetic energy minus potential energy of a system. This is kinetic energy minus potential energy of a system. If you have any doubt, you can ask me. Otherwise, we will go for next level of definition. So we will go for Lagrangian formulation. So this is all about Lagrangian formulation. And then we will go for different type of new definition.
Sir, by those paths for which action of a system is extremum. So do you mean it will follow the shortest possible path?
Extremum means either shortest or biggest. But in the natural thing, it will be shortest.
सर L is equal to T minus V, जो हम काइनेटिक एनर्जी माइनस पोटेंशियल एनर्जी लिए, तो इसके अलावा सर कोई दूसरा चीज नहीं लेंगे, मतलब यही सिर्फ
अगर आप दूसरा चीज लोगे इसको, तो ये न्यूटन्स लॉ ऑफ के इक्विवेलेंट नहीं होगा, तो हमारा पर्पस पूरा नहीं होगा.
अच्छा, मतलब कि लॉज ऑफ इक्वेशन को हमको मतलब निकालना है.
बेसिकली वही तो चाहते हो ना. बेसिकली हमने पूरी क्लासिकल मैकेनिक्स की पर्पस क्या है? पूरी क्लासिकल मैकेनिक्स की पर्पस है कि हम पोजीशन को टाइम के साथ वेरी कराएं, इजंट इट? सो उसको अगर पोजीशन को टाइम के साथ वेरी करा देंगे तो, और फिर मोमेंटम को भी हम देख लेंगे किस तरह टाइम के वेरी करेगा. ये कैसे पता चलता है? न्यूटन्स लॉ के थ्रू ही पता चलता है. मैंने बताया था इक्वेशन ऑफ मोशन इज व्हाट? ऑल अबाउट न्यूटन्स लॉ, डे 1, रिमेंबर?
यस.
हाँ. निश्चित रूप से उन्होंने डिफरेंट टाइप के फॉर्मूले ट्राई किए होंगे, ओके, लेकिन जो बेस्ट फिट हो रहा है वो कौन हो रहा है? T minus V. So why I am saying T minus V is not any physical quantity. T plus V is physical quantity. T minus V is just kinetic energy minus potential energy, isn't it? So this is all about, so in the day 1, what I have told you that we are doing a mathematical formulation of mechanics. So even if the principle of least action is purely mathematical philosophy, nothing to do with the physical thing. Action have not any meaning of physical thing. This is just all about this mathematical relationship. So why we have taken action such that L is equal to T minus V? Because we need that the equation of motion should come from this formulation. So when we will solve the problem, we can see.
That totally it is a heat and trial method. वो equation
this is not heat and trial method. There is nothing called heat and trial method. The person who is giving whole life to this calculation. I am just giving you the final gist. This is nothing called heat and trial method. He doing calculation, he tried to understand this. Then he have give this is my Lagrangian. This is heat and trial method for you. He was so smart. He was so smart that he wants this should behave like a Newton's law of motion. Then why it is heat and trial method? Huh? Yes. Ask some relevant question, okay?
Sir, how we get to know that this equation is behaving like equation of motion?
We want that should behave like a equation of motion.
Okay, sir.
Okay. We want. We are human being, na? So human being always focus on their final target. What is my final target? My final target is Newton's law of motion. Okay. Okay. So I think we should go for next level of all calculation and next level of derivation definition. So this is the last part of derivation and definition for Lagrangian formulation. After then we will straightforward go to different type of problems, and next 3 days will be only for the problems, but next 15 minutes we will go for different definition. For once we define Lagrangian, then we will go for definition and all different kind of thing. Okay, so what is L? L is nothing but T minus V, where T is kinetic energy and V is potential energy. But please mind it, the most important thing is that L will be function of generalized coordinate, generalized velocity, and maybe function of time. Means what is generalized coordinate? These are dynamical variable, and if number of dynamical variable will be equal to degree of freedom, then only we can say this is generalized coordinate. So how many number of generalized coordinate must be there? We will use how many number we are going to use. The number of generalized coordinate must be equal to number of degree of freedom. So how many number of QI you have? So number of generalized coordinate is equal to degree of freedom. This is equal to degree of freedom. So you have to always keep in mind, please. बड़ी बड़ी बातें तो अलग अलग जगह पर है, but you have to always keep in mind that number of generalized coordinate must be equal to number of degree of freedom. Then only you can define the Lagrangian, because Lagrangian is function of generalized coordinate and generalized velocity. This is function of generalized coordinate QI and generalized velocity QI dot. So you have more than one generalized coordinate, and for every generalized coordinate we have one equation of motion. So for QI, one equation of motion, QJ, another equation of motion. So you have, if you have n number of degree of freedom, then you have n number of equation of motion. So this is very interesting. So we will solve n number of independent differential equation to solving the system. Now let's go for generalized momentum. Now, if QI is generalized coordinate, GC is generalized coordinate. If QI is generalized coordinate, then PI is identified as generalized momentum. And what is PI? Please mind it, this is QI and then you have PI. If this will be QJ, there is PJ. If QI is generalized coordinate, then PI identified as generalized momentum corresponds to QI or conjugate to QI. Conjugate to QI. And what will be PI? The PI is defined as del L upon del QI dot. Del L upon del QI dot. What is QI dot? Is nothing but generalized velocity. Generalized momentum can be defined that Pi is del L upon del Qi dot. So dimension of generalized momentum I am writing this thing by generalized momentum, GM. The dimension of generalized momentum depends on what is dimension of generalized velocity or generalized coordinate. So suppose it is linear, then it is linear momentum. If Qi is linear, then it is linear momentum. If Qi is angular, then it is angular momentum. We will see. So you cannot say in the same problem, you have all generalized momentum have same dimension. It may be linear momentum, it may be angular momentum, depends on what is your generalized coordinate and then what is your generalized velocity. Suppose generalized coordinate is x, then its conjugate momentum is px, which is linear. Suppose generalized coordinate is theta, its generalized momentum is p theta, and that will be, you will see that its dimension is of the angular momentum. So you can, yes?
If derivative is not equal to 0, it means it's a generalized coordinate, right?
Who said this? What is this? What is this? From where we are this all thing? Huh?
Dynamical variable, what is generalized coordinate, which is dynamical variable?
We have, listen. First of all, we have discussed what is dynamical variable. Say yes or no?
Yes, sir. dq upon dt is not equals to 0.
No. There's dq upon dt is not equal to 0. That is, we have discussed.
Yes, sir.
Then this is the same generalized coordinate. Why you are again taking that thing now?
No, sir, because I am just confirming, because here time, if we take the derivative of time with respect to
this is all about Lagrangian. This is not generalized coordinate.
Yes, sir.
This may be function of time. Oh, come on. You are just wasting the time of your and whole class. What I am saying, Lagrangian is generalized coordinate, generalized velocity, and may be function of time. Is that I have said that time is generalized coordinate?
No, sir. Oh, that's what I am asking.
I have said Lagrangian is function of generalized coordinate, generalized velocity, and time. That's it. Time is the another parameter, nothing to do with the generalized coordinate. Lagrangian may be function of time, may not be function of time.
Okay, here time is maybe constant.
Huh? Time is another variable.
Okay, sir.
Okay? Don't be confused. Don't be confused with your unnecessary questioning. Whatever I am giving you the definition, just follow that definition. Because unnecessary, if you will go give you your definition, it will be spoil each and everything. I have said Lagrangian is function of generalized coordinate, generalized velocity, and time. That's it. So how you are now saying that time is generalized coordinate? Okay. So this is your generalized momentum. So we will, when we will go for problem, then we can see which type of momentum is there. Now next is the very important, and that is cyclic coordinate. Let's go for cyclic coordinate. So what we can have? We can have n number of generalized coordinate. Suppose you have Q1, Q2, and you have Qi, and you have generalized velocity Q1 dot, Q2 dot, and then met with function of time. So there may be n number of generalized coordinate, don't worry. And time is the different variable. If you are talking about motion, then time is already there. Now, if Qk is generalized coordinate, Qk is some particular generalized coordinate. I am talking about particularity. So Qk is some generalized coordinate. Qk is particular generalized coordinate and Lagrangian L is not explicit function of QK. Lagrangian is not explicit function of QK, but it is implicit function of QK. Don't worry. So if Lagrangian is not explicit function of QK, means del L upon del QK is equal to 0. Not explicit function. We have discussed this Lagrangian is not explicit function of QK, means del L upon del QK is 0. Then QK is identified as cyclic coordinate. Then QK is identified as cyclic coordinate. What will happen when QK is cyclic coordinate? Then let's go for equation of motion for QK. Please, QK is generalized coordinate, but Lagrangian is not explicit function of QK. It may be possible. It may be possible. When we will solve, we can see. If this kind of situation will happen, then let's see what is going to happen. Then we have the equation of motion corresponds to QK is identified as d upon dt del L del QK dot minus del L upon del QK is equal to 0. So QK is identified as cyclic coordinate, and now del L upon del QK is 0 because QK is cyclic coordinate. So this term will be 0. So we have d upon dt del L upon del QK dot is equal to 0 because this is 0 due to cyclic coordinate, isn't it? This is 0 due to cyclic coordinate. Then this term must be 0. And what is del L upon del QK dot? What is del L upon del QK dot? Del L upon del QK dot is momentum. आप मत बोलिए, मुझे बोले, आप मत बोलिए, आप मत बोलिए. Don't talk, let me talk. Okay. When I will ask you, then you will talk. Then del L upon del QK dot, del L upon del QK dot is some momentum associated to QK is PK is identified as constant. Then momentum corresponds to cyclic coordinate will be constant and conserved. So what we can make a new statement. We can make a very strong statement that momentum conjugate to cyclic coordinate. Cyclic coordinate. What is cyclic coordinate? Is QK. Momentum conjugate to cyclic coordinate QK is PK is constant of motion. Constant of motion. So what we have? We have conservation of momentum. We have conservation of momentum. So once you identify cyclic coordinate, the momentum associated to that particular coordinate or that particular dynamical variable must be constant in nature. And its momentum can be linear momentum, it can be angular momentum, it will depend what is your dimension of coordinate. So this is a very interesting thing. The cyclic coordinate is the wonderful mathematical tool from which we can easily talk about conservation of momentum or angular momentum. We will see when we will do the problem, everything will be clear, don't worry. Right now, you have to just identify, just listen and just believe this is the definition of each and everything. We will see each and everything when we will solve the problem. So it is, so first thing what we have seen, that number of generalized coordinate must be equal to number of degree of freedom. Second thing is the very important thing that Lagrangian may be function of time, may not be function of time. And third thing, you have to know what will be the generalized momentum. What is generalized momentum? And then if you know the generalized momentum, then you can identify the cyclic coordinate. Cyclic coordinate will tell you all about explicit function or implicit function. And then once you get the cyclic coordinate, you can talk about the basically conservation of momentum. And if I am talking about conservation of momentum, I am just talking about conservation of angular momentum as well as linear momentum. So this is the whole definition for Lagrangian formulation. So if Lagrangian we have defined from the principle of least action, then each and everything will be defined such that, and we will see that each and everything will work very nicely. So let's, if you have any doubt, now you can ask me. If you have any doubt, you can ask me. This is a just definition. You have to believe on this. You have to believe on this. I am always talking. Mathematics is just like a religion. Either you have to believe or you have to not believe. And here there is no other scope. You must believe on this all mathematical thing. But the beautiful part is that it will work very beautifully. So let's go for problem. One basic problem at least we can do.
So
yes.
What is explicit function? Can you define it?
We have defined explicit function earlier. If del L upon del QK is equal to 0, then it is explicit. You have to just check it, okay? If this works, then it is explicit. For example, suppose sum L is half m x dot square. Suppose this is only free particle, half m x dot square. Okay?
Okay, sir.
Then del L upon del x is equal to what? 0. Have you seen x there?
No, sir.
No? Then x is explicit. Then x is not explicit function. Lagrangian is not explicit function. Then x is cyclic coordinate.
Okay, sir.
Okay?
Okay, sir.
And suppose I have half kx square. Then what will happen? Del L upon del x is equal to kx.
Yes,
Suppose
sir.
minus, I will take minus. Then it is not equal to 0. Then it
Yes,
is explicit function. Okay?
Yes, sir.
Of x. Okay or not? So you have to just
Okay,
do
sir.
the calculation, then only you can say it is explicit or not. Okay?
Okay, sir.
Okay. Okay. So let us try to go for one particular problem. First, I will go for definition problem. Suppose this is just for the clearing of definition, nothing else. Lagrangian is given as half m x dot square plus y dot square plus mgy. Suppose this is your Lagrangian, and this Lagrangian is for 2 DOF, 2 degree of freedom. If this is the Lagrangian, then this is for 2 degree of freedom. Okay? Now, the first thing, what is generalized coordinate? Now, you can give me answer. What is generalized coordinate here?
X and Y.
Very good. The generalized coordinate is X and Y because, please, Y is not here. Sorry, Y is here, X is not here. But X dot is here. isn't it? X dot is here, X is not here. So don't worry if X dot is not, if X is not there. Agreed or not? If I am writing this thing, you can see this Lagrangian is function of y, x dot, y dot, but it is not function of x. So don't worry. If it is not function of x, means it is implicit function of x. Why? Because x dot is there. So whenever you want to see the generalized coordinate, what you will see? You will see this dot square term. How many dot square term is there? Obviously, there is 2 dot square term because we have 2 degree of freedom. So there is generalized coordinate is x and y. I will show you why it is not visible. Why it is not visible? What is generalized velocity? Obviously, x dot, y dot, because 2 degree of freedom, 2 independent motion. Then you have to always 2 degree of freedom. Now, what is generalized momentum? Sorry, generalized coordinate, generalized velocity, generalized momentum. So we have generalized coordinate x and y. So we have 2 momentum. So first momentum I will say px, and this will be del L upon del x dot. What is this value? This value is equal to mx dot. So this is linear momentum. You can easily see. This is linear momentum. Second is py del L upon del y dot equal to m y dot. This is your py. What is cyclic coordinate? So if you will just check, very good. Del L upon del x is equal to 0. Del L upon del x is 0. So x is cyclic. Isn't it? Next we will go for del L upon del y. And if you will calculate del L upon del y, this is equal to mg. This is not equal to 0. So y is not cyclic coordinate. Y is not cyclic coordinate. So now, which one is the conserve? Obviously, px will conserve because x is cyclic coordinate. We can show it. Now, if you have any doubt, you can just ask me. Otherwise, you go for equation of motion. Everything is crystal clear. This is definition. Unless until you will not understand definition, not solve problem.
सर ये px is equal to del x upon del x dot. सर ये मतलब लीनियर मोमेंटम को एंगुलर मोमेंटम के इक्वल लिखा, सर ये समझ नहीं आ रहा.
ये क्या बकवास है यार, क्या बोल रहे हो तुम? कुछ भी पूछते रहते हो.
सर
कहाँ लीनियर मोमेंटम का एंगुलर मोमेंटम के टर्म में लिखा है?
नहीं सर, px is equal to लिखा ना, ये समझ में नहीं आ रहा सर, कैसे किया है?
तुम्हारा दिमाग खराब है यार. ये अभी मैंने पढ़ाया है कि नहीं? Pi is equal del L upon del QI dot.
ओके सर, ओके सर.
अरे भैया भांग खा करके बैठे हो क्या जी?
सर नहीं, ये तो निकल गया था सर. ओके,
हाँ,
सॉरी सर.
भैया कुछ भी मत पूछा, ठीक है? जब जो चीज पहले बता दिया हूं वहां पर नहीं पूछ करके अननेसेसरी क्वेश्चन पूछते हो तुम. We are using all the definition. What is Pi? What is Pi? Pi is nothing del L upon del Qi dot. Then it is very simple. Now let's go for equation of motion. So what is equation of motion? The first equation of motion will be d upon dt del L upon del x dot minus del L upon del X is equal to 0. Then you can just go for it. What is del L upon del X dot? So this is d upon dt mx dot minus what is del L upon del X? This is 0. This is 0. And now again you can see from here we can again prove that from here we can prove mx dot is constant. And from the cyclic coordinate we have from the cyclic coordinate here we can prove this is constant. Mx is constant, isn't it? And then you can go for equation of motion for y. What is equation of motion for y? D upon dt del L upon del y dot minus del L upon del y is equal to 0. And when you will go for this, you can easily solve m y double dot, and you can just write it just like this, d upon dt m y dot minus mg must be equal to 0, and this will be my double dot minus mg is equal to 0. So now look at what is this thing. If you will write it, this thing is m d square y dt square minus mg is equal to 0. This thing is just equivalent to Newton's law. Now you can see from Lagrange's equation we have Newton's law, and here this is also Newton's law. Why it is Newton's law? Because you can see in this potential there is not, sorry, in this Lagrangian there is not any x dependent potential. This is the kinetic energy part. You can see this is the kinetic energy part, and this is with the minus sign. So you can write T minus V. So this is from the minus sign is the potential energy part. So this is kinetic energy. This is potential energy. And you can see there is not any x. There is not any x variable in a potential. If there is not any x variable in a potential, how force will act in a direction of x? Because it is cyclic coordinate. And hence, if force is not in a direction of x, then momentum will conserve. That is Newton's law. What is conservation of momentum? If external force is 0, then momentum is conserved. So from this potential, external force will define from the potential actually. You can see external force is defined from the potential, and you can find this is working very nicely. Don't worry, this problem will not come into examination, but we are doing this problem such that we can understand definition. So I will suggest you go and read definition once again and try to do this thing again and again. Okay? So if you have any doubt, you can just ask me on calculation.
सर ये लास्ट का एक्सप्रेशन नहीं दिख रहा है.
कौन ये एक्सप्रेशन?
जी ये
कर लीजिए, आप इसको कैलकुलेट कर लीजिए. ये m ये दिख रहा है?
हाँ ओके सर, ये दिख रहा है.
ये दिख रहा है ना? तो इसके बाद ये लिखने में तुम्हारे लिए क्या हो रहा है? ओके ठीक है, वही चीज को फिर से लिख दिया, सेकंड ऑर्डर डिफरेंशियल के टर्म में लिख दिया.
Sir, if Lagrangian contains xy term, then how we will solve the equation?
Yes, you can solve. We will see. You have Lagrangian content xy, then there is not any cyclic coordinate.
Actually, I am asking that product term, sir. Product xy product.
Yes, x and y. Yes, there may be. Why not? You can have this kind of situation.
Okay.
Minus
sir, then
kxy.
momentum is not conserved.
Not conserved. Yes.
Sir, my doubt was that the Lagrangian content we are solving for x and y differently. So when both the term contains, that means at one point x will be constant and for other y will be constant.
No. It is just function of x and y. Don't worry. There is nothing called cyclic coordinate.
Okay.
Here you can, if you will calculate del L upon del X is not equal to 0, as well as del L upon del Y is not equal to 0. Don't worry. Isn't it? This is the doubt actually. Just talk about the system. You are not taking that first time it is cyclic, second time it is cyclic. This is not going to happen. I am just talking about system. In one particular system, there may be either cyclic or not cyclic. It is not depend first time it is cyclic or second time it is cyclic. And suppose if you will solve this equation of motion, don't worry, just solve this equation of motion. What is there any problem? You will suppose this is your Lagrangian, half m x dot square y dot square minus kxy. Suppose you will solve d upon dt del L upon del x dot minus del L upon del x, then what will happen? Mx double dot minus minus plus ky is equal to 0. This is your equation of motion.
Okay, sir.
And similarly, you can get another term. Another you will solve d upon dt del L upon del y dot minus del L upon del y is equal to 0. Then you have my dot plus kx is equal to 0. They are coupled equations, so why this is coming there? Okay.
Okay,
Whatever
sir,
the
thank you.
mathematically come, you will just take it. Don't worry, we will discuss when we will discuss the problem, then it will become more clear. Hypothetically, it will not clear. Okay. So let it be. I will stop this session. But I request you, all of you, your questions are not very relevant. So this is not very relevant, very frankly, because you have to go for the examination. And in the examination, you must focus what we are doing. So I have seen only 1 and 2 question is also there, also not very relevant. Means you are not focusing on a class. What you are doing, you are asking your hypothetical thing. Don't ask hypothetical thing. In any class, don't ask unnecessary hypothetical thing. What you have to ask? You have to ask the actual thing what is going to happen. Okay, so your question is more hypothetical than the real, and this is so. Please, from next class we will go for the very tough. Next 3 days very tough for you. Okay, so do practice yourself very hard and try to revise this thing. I think you people are not revising properly. So why you are asking this type of questions? Because each and everything I have discussed, then I am going to do this. So, okay, anyway. So tomorrow we will go for the basic problem of Lagrangian. So tomorrow is the first encounter. This is not problem. This is just a basic definition. Tomorrow we will go for the problems.
Okay, sir.